So we're going to go through the periodic table notes today. Make sure that you have the worksheet to fill in the blanks that looks like this as we go through. So your essential questions for this particular unit. You're going to be able to answer how was the periodic table organized, and how do scientists use the periodic table to describe the properties of the elements and determine the uses of the elements. Remember, you do not have to write these down, but it will be helpful if you know what they are and you'll be able to answer them later. All right, so this is another intro screen. You don't have to copy this down. And here's the periodic table, which you already know. And this is Dmitri Mendeleev, okay? And he was considered to be the father of the periodic table. He was the first scientist to notice relationships between the elements. So he arranged the periodic table based off the mass of the elements. Okay? So using his findings, the periodic table is known to be organized based on the physical and the chemical properties and the atomic number, which we talked about yesterday. And the atomic number is that number usually at the top right or at the top of the periodic tile. Okay? And he also said that properties of unknown elements could be predicted by the properties of elements around the missing element. And they're also arranged by on the periodic table by the atomic mass, which is that decimal number at the bottom. Okay. So at the time you have to go back and look at this picture, he looks to be kind of old, and I'll go back. So Mendeleev, he looks pretty old. He was basically in the early part of the 1800s, and there were plenty of elements that had not been yet discovered. And so he said that if we sometime in the future find these elements and their properties, we can use that to predict what element we haven't yet discovered. So the big thing is to sort of understand or see what his idea was based on the atomic mass and the physical and chemical properties and the atomic number. So that's how they're actually put together. But he also looked very closely, and he was pretty right on most of the elements on the periodic table. So the periodic table. Let's start off with the blank periodic table that I handed out to you. It's on your worksheet, like so. And we want to look at what we call a column or a group. As you can see right here, the column or a group or a family, there's 18 columns on the periodic table. So a group or a family, and that's for us, that's basically going up or down. Those are going up or down. All right, there are 18 columns. Here's 18. And 2. Then this is 3 going down. Okay, and you can count them on your own. So if we were to talk about the rows, they're also called periods. Okay, so the rows are periods, and they go obviously from left to right. So on a test or a quiz, if I asked you a column on a periodic table is called what, you would tell me a group or a family. If I asked you a row on the periodic table, you would say period. Okay, so there are 7 periods, and I'll use a different color, to yellow. So there are 7 periods. You have 1, 2, 3. You can go all the way down, and here's 7. Oh, excuse me, that is 7, and this right here goes in between here. Okay. So there are 7 rows in the periodic table. So don't worry about really these guys. Really, they just fill in there. We'll talk about that later on, or basically when you get to the chemistry unit, the chemistry course at the high school. Okay. All right, so some general trends in the periodic table. So as we look at the periodic table, I would like you all to understand that the atomic size increases as you go down the table, and the atomic size decreases from left to right. Okay, atoms on the left side of the table want to lose an electron. and atoms on the right side of the table wants you to gain an electron, except for that last column. Okay, 18 is not going to want to do anything, and we still go into it, and we'll go into that a little bit later. Okay. So metals, nonmetals, and semi-metals. So, all right, so metals, nonmetals, and semi-metals. Metals are to the left, right here. So the metals are to the left. And of the staircase. So your staircase is here. So we have our staircase here. So everything to the left are metals. Okay. Semi-metals is going to tell you, right, I'm going to tell you right now, they're also called metalloids. And that's what I've always been told. That's what I've always learned. So when you hear me say metalloids, those are your semi-metals. And these are the ones that hang around or they touch the staircase. So they hang around or they touch the staircase somehow, some way. So these are your metalloids or your semi-metals. Okay. So, all right, then we have our nonmetals. And these guys are to the right. And I'll use green. So these are our nonmetals. And I'll do NM for that. All right. So you're going to have to look at the periodic table because there are two metalloids that touch, but they are not metalloids. Okay. I'm not going to say to memorize the metalloids. It's going to be obvious when I say which one is always going to be over here and what is always going to be a metal, or it's always all over here, so it must be a non-metal. So don't worry about memorizing specific non-metals on the periodic table. Excuse me. The only non-metal on the periodic table is hydrogen. That is over here. Hydrogen is a gas, so it does not follow all the rules to the periodic table like other elements, but it is considered a gas and is not a non-metal, and it is a non-metal. So we won't go into a lot with hydrogen. There's a lot of weird things that go along with him. It's a pain in the butt, but I just wanted to let you all know that's why hydrogen's over there. It has a lot of rules it does not follow. Okay. So our semi-metals are metalloids. They touch the staircase, like we just said. Non-metals are to the right of the staircase. Okay. And hydrogen is the only metal on the metal side. All right, so metals. Elements that conduct electricity, heat well, and they have a shiny appearance. Okay, they can be shaped by pounding or bending, which they're malleable. They can be drawn into a long wire, which is ductile. And except for Hg, which is mercury, which is a liquid, the rest are solid at room temperature. Okay. So our nonmetals, they're found to the right of the periodic table. Many of them are gases at room temperature. Solid nonmetals are often dull and are not malleable or ductile. Our metalloids, think of it as it's quite not a metal and it's not quite a non-metal, so that's why it's a metalloid. They have properties of both metals and non-metals, and it's found on both sides of the staircase. So, how to group the periodic table. So, group 1 is called the alkali metals. Most are reactive metals on the periodic table, and they're rarely found free in nature. Group 2 are the alkaline earth metals, and they're still quite reactive. So, remember on your periodic table where the groups are. Okay, we have group 1 through 18. Groups 3 through 12 are your transition metals. They're found freely. They're right here. They're found freely in compounds in nature. Generally, they're less reactive than most other metals. And metals are very important in industry. So they're alloys. They are used in many applications. There's 2 or more metals are combined. Those are where alloys are. Group 16, the oxygen family, also known as the Challengens, I'm going to pronounce it wrong. And group 17 are your halogens, and they're the most reactive nonmetals. Group 18 are the noble gases. This is your inert gases, and they're non-reactive. Like your neon, your argon, your krypton, your xenon, and your helium. All right, so the special rows in the periodic table right here are your lanthanides and your actinides. They're also rare earth metals, and they're thought to be rare, but were found in fact to be hard to isolate to be in a pure form. All right, we're not going to really talk about the transition metals. We won't spend a lot of time on them. There are a lot of rules to follow them than the others. Just remember, an alloy is just 2 or more metals, and the special rows, we're really not going to go into them. But with these lanthanides and the actinides, just make sure that those are the ones at the bottom. And just when they're supposed to be addressed, we will address them. Make sure you take thorough notes, and you can go ahead and take your notes quiz. If you have any questions, please let me know.
I would say I can show up. I can be a